Okay, welcome everyone. So we're going to continue talking about integrals. Today we're going to talk about how to find the area between two functions, and eventually we're going to move forward, and after the area we're interested in finding the volume using integral. So objective, we're going to talk about area, and then we move forward to find the volume. We are in chapter 6 and section 6.1. Well, what we learned so far? We start talking about moving from the Riemann sum and taking the limit of those subintervals and define the definite integral by taking the limit of Riemann sum. Then we introduced some shortcuts, some nice formulas that help us to calculate the integral, the definite integral or indefinite integral. Today we're going to talk about the area bounded between two functions in xy plane. So, definition. Definition of area between two functions. So let f of x and g of x be two functions. We have two functions in xy plane, and then let x be bounded between a and b. And for the sake of this definition, suppose f of x is greater than g of x. Eventually, I'll tell you can use the absolute value to make sure that the area is not negative. In this case, the area bounded between these two functions, while x is in between a and b, the area is equal to definite integral while x bounded between a and b. So these are our lower bound and upper bound. And here, you're going to have your y value. Your y value is changing between f and g. So you're going to have f of x minus g of x dx. You're taking the integral with respect to variable x. Well, okay, how do we visualize that? This is my x-axis, this is my y-axis, and suppose this is my function f. And down here, I have my function g. And I'm interested in finding the area bounded between these two functions as x ranges between a to b. This is the definite integral while x bounded between a and b, and my y is changing between f and g. So as you can see, the height is the difference between f and g. Well, you might say, what if x, lower bound and upper bound, are not given to us? So note that, just a quick note for you. If the upper and lower bounds are not known, It's usually the case that the function f and function g, they're intersecting at some points. The graph is going to be like this. This is your function f, for example, and this is your function g. These two graphs are intersecting at these 2 points. Well, to find the points of intersection between f and g, we set f equals to g and solve for x. Set f of x equals to g of x and solve for x. In that case, you can find the lower bound and upper bound for your x value. Example. This example says, well, find the area of the region bounded so my function is e to the x bounded between y equals to e to the x and y equals to x. And here your x is also given. It says x must be bounded between 0 and 1. Well, okay, 0 and 1. I'm interested in visualizing this area. Which function is the top function? Which function is the lower bound function? Which one is f and which one is g? How to make sure I select these 2 functions correctly by graphing. So let's graph this one. This is my x-axis, this is my y-axis. So here, this guy is just a line y equals to x at between 0 and 1. So 0, 0, and 1 and 1. This is y equals to x. Okay, wasn't that bad. What about e to the x? Remember that e to the x is just an exponential function. So if I plug in 0 here, or y equals to e to the x, what do I get? E to 0 is going to be 1, and when I plug in 1, it's going to be e raised to the first power. Okay, here I have my 1, and then e to the x. So this is my 1, and this is my 1 here. Your function is going to be like this. So this part of the function. This is my e to the x. But the question says, hey, I'm interested in finding the area bounded between these 2 y values, and x is ranging between 0 and 1. So 0 and 1, okay. It means that I'm finding this area here. So your top function is e to the x, and below e to the x, you have y equals to x. Very well. So I know the formula says the area is equal to definite integral. X is bounded between 0 and 1, and then e to the x minus x dx. Now, we just start taking the integral. Remember that. Let's write this in fonts for you. The integral of e to the x dx is e to the x plus constant of integration, and the integral of x dx is equal to a half x squared plus c. So the area is equal to e to the x minus x squared divided by 2, while x ranges between 0 to 1. So I'm going to plug in 1, then I'm going to plug in 0 and do the subtraction. So it is e to the first minus a half minus e to the 0 minus 0 squared divided by 2. This is equal to e minus a half minus 1, and this guy is just 0. So e minus 3/2 is the area of this region bounded between these two functions, while x is in between 0 and 1. This is how it is. Well, next example says, hey, find the area of the region bounded between these two functions. Find the area bounded between y equals to x squared. So we have a parabola, it opens up, and the other guy is y equals to 2x minus x squared. Well, okay, do we have anything about x? We don't know what a and b are. My suggestion for you is to try to graph it first and see what region you're dealing with. Then do the algebra to make sure that your calculations confirm the graph and the region bounded between these two. So let us take a look at the graph together. Here we have our x-axis, here we have our y-axis. So y equals to x squared. Y equals to x squared, I already know how to graph this guy. 0, 0, 1, 1, negative 1, 1. So this is my y equals to x squared, and it's symmetric with respect to y-axis. So this is y equals to x squared. X squared here. The second one is also a parabola, but remember that the leading coefficient is negative, so it's going to be concave down. Well, okay, 0, 0. If I plug in 1, I get 1 again, and I know the graph behaves like this. If I continue the rest of the graph, it's going to be like this way. So this guy is 2x minus x squared. So the area bounded, sandwiched between these two parabolas, is going to be this little area here. Our goal is to find this area. What is this area? A to b, the top function is 2x minus x squared, 2x minus x squared, minus the lower function, which is just x squared, dx. But what is a? What is b? You can take a look at the graph and say, hey, x is bounded between 0 and 1, but to make sure that 0 and 1 is the correct upper bound and lower bound for your integral, you have to do the algebra. So to find a and b, set x squared equals to 2x minus x squared. So we need to solve for x. It means that we need to form a quadratic equation. So you can add x squared to both sides. You get 2x squared equals to 2x. Then subtract 2x from both hand sides, and you get 2x squared minus 2x equal to 0, or x squared minus x equal to 0, or x times x minus 1 is 0. So as you can see, x is 0, or x is 1, between 0 and 1. 0 and 1. Okay, so the rest is easy. Area is equal to the integral 0 to 1, 2x minus 2x squared dx. I already know how to handle x to the n integral. Recall that when you have the integral of x to the n dx, it is equal to x to n plus 1 divided by n plus 1 plus constant of integration. Okay, so here we have the area equals to, I get x squared minus 2x cubed divided by 3. My x bounded between 0 and 1. I'm not really worried about 0, because if I plug in 0 here and here, the outcome is 0. So my main concern is 1. It is equal to 1 minus 2/3 or 1/3. This guy is the area bounded between these two parabolas, while x is bounded between 0 and 1. Very well. Now we're interested in finding the area bounded between 3 functions. 3 functions, okay. Question says, find the area bounded between y equals to sine of x and y equals to cosine of x, and my x is bounded between 0 and pi over 2. Pi over 2. Well, okay, we're dealing with trig functions. As you know, both of these two functions on their domain, they continue both sides. Both of them are oscillating to the left, to the right, and they never stop. Luckily for us, we have x bounded between 0 and pi over 2. Let us take a look at the graph first, then check the algebra. So this is my x-axis, this is my y-axis. Sine x, okay. I know sine x is between 0 and pi over 2. I'm not going to continue this that much. So 0 and pi over 2, and at pi over 2, I know my sine x is equal to 1. So just 1 here. This is my sine x. Okay, well, what about cosine function? Remember, cosine function at pi over 2 is 0. Okay, and at 0, it's 1. So my cosine function behaves like this. This is my cosine function. Okay, the area bounded between these two functions. Is it this area? Is it this area? Is it this area? Remember that your y is changing between two y values. Here you have cosine on top, and down here you have your sine. So the first part of the area bounded between these two is going to be this piece here, between cosine and sine. This is the first piece. Does this part count? Of course not. If you count this part, it means that you are finding the area between sine and x-axis, or between cosine and x-axis. But the question doesn't mention anything about x-axis. It says the area bounded between sine and cosine. Cosine and sine, sine and cosine. So the second part of this area is here, between sine and cosine. Your line is changing between these two functions. Okay, not that bad. But the thing is that when you're trying to set up your integral to find the area, you're dealing with two areas. On top, you have cosine. Down here, you have sine. For the second part, you have sine as a top function, and down here, you have your cosine. So it means that we need to calculate this area. We need to calculate this area and then add them together to find these two areas. But what is this number here? My x is bounded between 0 and pi over 2, but I cannot say, hey, between 0 and pi over 2, the top function is cosine. Why is that? Because if I look at this piece, the top function is sine. So I need to divide this up between these two intervals. The first interval, and then calculate the area on this interval, then calculate the area on this interval and add them together. So the dividing number here, sine x equals to cosine x, on this domain between 0 and pi over 2, the only correct answer is pi over 4. At pi over 4, these two graphs, these two functions are intersecting. So it means that if you want to calculate the area, this area is going to be the area between 0, pi over 4. Between 0 and pi over 4, the top function is cosine function. And down here you have sine with respect to variable x plus the integral. Now you're taking the integral while x ranges between pi over 4 to pi over 2, pi over 4 to pi over 2. But now the top function is sine, and down here you have cosine. So it's going to be sine minus cosine. Pi over 4 to pi over 2, sine x minus cosine x dx. My next question is, well, can I just find one of these areas and multiply by 2? Is it possible to do that? Do I have symmetry? Are these two the same area? We're going to investigate that as well. Very well. So recall that the integral of sine x dx is negative cosine x plus c, and the integral of cosine x dx is sine x plus c. We're going to find each of these integrals and add the outcomes together. So the area is equal to, so the integral of cosine, which is sine x, and negative sign is going to be cosine plus cosine x. My x is bounded between 0 to pi over 4, plus the second guy here, the integral of sine is negative cosine, so negative cosine x, and the integral of negative cosine is going to be just minus sine x, 0 pi over 4 to pi over 2. Okay, the rest is just plug in pi over 4 and then 0. Here you have the area equals to 1 over square root of 2 plus 1 over square root of 2 minus, this is going to be 0 and this is just 1, plus, here if I plug in pi over 2, cosine is going to be 0, and here I have minus 1, minus, now I'm going to plug in pi over 2, which is negative 1 over square root of 2 minus 1 over square root of 2. So the area is equal to 2 over square root of 2 minus 1. And if I distribute this negative sign here, I get negative 1 plus 2 over square root of 2. So what I have 4 divided by square root of 2 minus 2. I can simplify this more by using a calculator, or here you can just say that I have 4 times square root of 2 divided by 2 minus 2, so you get 2. Area is 2 square root of 2 minus 2. You can leave it as it is, or you can use your calculator to simplify this area and approximate this. Okay, now let us talk about volume a little bit. How do we find the volume?